All right, let's get right into it. For the past 5 years, the AI race has felt like a heavyweight boxing match, right? The winner was always the biggest giant with the most power. But that's all changing. Right now, as we speak, the rules of the game are being completely rewritten. We're seeing this massive pivot away from just brute force and towards, well, towards actual brain power.
And this quote? This is basically the starting gun for this whole new era. You have to understand, when Ilya Sutskever talks, the entire AI world stops and listens. I mean, this is one of the key brains behind OpenAI, and now he's running his own shop, Safe Superintelligence. So when he comes out and says that research, not just bigger computers, is what's going to create the next big breakthrough, yeah, that's a huge deal. It's a signal that the ground is literally shifting beneath our feet.
So, here's how we're going to unpack all of this today. First, we'll look back at the age of scaling. Then we'll jump into this new age of research. After that, we'll get into a tricky problem called the learning machine's dilemma and see how the industry is building a blueprint for a safer AI. And we'll wrap it all up by looking at what's next, the next AI frontier.
All right, part one, the age of scaling, or as you could call it, the reign of the giants. This is the era that put AI on the map for everyone.
So for the last 5 years or so, the game plan was, well, it was dead simple. Bigger is better. That's it. If you wanted to make progress, you just threw more stuff at the problem. More data, more computing power, bigger and bigger models. It was basically an arms race measured in GPUs. And let's be honest, only the tech giants had the cash to play that game.
And this was the magic recipe, right here. It worked like a charm, every single time. Step 1, buy more GPUs. Step 2, shovel in more data. Step 3, make your model even bigger. And boom, step 4, you get a better model. It was so predictable, it was almost like an assembly line. But that assembly line is starting to sputter.
And that brings us right to our next chapter, a new age of research. This is where the whole game flips from being a battle of budgets to a battle of brains. Okay, so here's the absolute heart of the issue. That beautiful, predictable curve we were just talking about, it's bending. The law of diminishing returns has slammed into AI hard. Think about it. A few years back, if you doubled your compute, you got a way better model. Now, you double the compute and the cost, and you might get a tiny little bump in quality. That old brute force approach is just not paying off anymore.
And this really lays out the whole shift perfectly. The scaling era was all about more. More GPUs, more data, bigger, bigger, bigger. This new research era, it's all about better. Smarter ideas, more efficient models, completely new architectures. The bottleneck isn't your checkbook anymore. It's the quality of the ideas coming out of your lab.
So what does that actually mean? Well, we're talking about fundamental, game-changing ideas. Stuff like making models that can actually teach themselves to get better over time, or creating architectures that are way more efficient, or the really big one, getting these things to actually reason. These are the really tough nuts to crack, and it's what all the giants are pouring their research dollars into because they know they can't just buy their way to the finish line.
Okay, so this new push for smarter AI brings us to a really big problem. Let's call it the learning machine's dilemma. Because you know what they say, with great power comes great risk.
So what's the dream here? The holy grail is an AI that doesn't just stay frozen in time. We're talking about a model that learns from every conversation, that updates its understanding of the world every single day. I mean, it sounds amazing, right? But it also opens up a total Pandora's box of problems. The biggest question of all is, what is it learning?
And one of the weirdest technical hurdles is something called catastrophic forgetting. And it's exactly as bad as it sounds. Imagine you teach an AI a new skill, like how to code in a new language, and in the process, it just completely forgets how to speak English. It's a massive, massive problem for anyone trying to build an AI that can learn on the fly.
But forget the technical stuff for a second. The real ghost haunting every AI lab is this, the name Tay. For anyone who doesn't remember, this was Microsoft's chatbot they let loose on Twitter. And within 24 hours, the internet had turned it into a vile, racist monster. It was a complete disaster, a total PR nightmare. And you can bet every single one of the giants working on this stuff has a giant sign in their lab that says, "We cannot have another Tay."
And that deep-seated fear of another Tay is exactly what led to what we're talking about now, the modern blueprint for a much safer AI. The industry has spent years and billions of dollars making sure that never, ever happens again.
So why did Tay fail so spectacularly? Looking back, it's almost comical how badly it was designed. It had 3 fatal flaws. 1, it basically drank straight from the toxic fire hose of the internet, believing everything it was told. 2, it learned instantly, in real time. And 3, it had zero safety guardrails. No filters, no nothing. It was basically a sitting duck.
The way things are done today is the polar opposite. It's all about layers of defense. First, all the data coming in is filtered like crazy. Anything even slightly weird gets flagged for a human to look at. And this is key. The AI doesn't update in real time anymore. It's all done in controlled batches. And even better, they use these cool reversible updates, which means if a bad update does get through, they can just hit an undo button and roll it back. It is a completely different universe of safety.
And this chart really breaks down that modern fortress. For every single thing that went wrong with Tay, there is now a specific, engineered defense. So toxic data coming in? Nope. Gets hit with aggressive filters. Instant learning? Nope. Now it's controlled batches with a human watching. The AI going off the rails, it gets stopped by a final safety checkpoint before you ever see the response. And the model getting permanently messed up? Not anymore. They use these things called reversible adapters. You can think of them like safe, temporary plugins that can be unplugged in a second if they cause trouble. This isn't just hoping for the best. It's serious, professional-grade safety engineering.
Which brings us to the final act, the next AI frontier. Because everything we've talked about, the shift to research, this obsessive focus on safety, it's all pointing to one massive, high-stakes endgame, the race to create safe superintelligence.
And really, if you take away one thing from all this, it should be this. The entire game has changed. The next giant leap forward in AI isn't going to come from building a bigger machine. It's going to come from a better way of learning.
So that leaves us with a pretty big question, doesn't it? The last era of AI was one with brute force, with raw compute. But now, as this new era kicks off, you have to wonder, will the next one be one with caution? Will the winner be not the fastest, but the safest?